And away we go. So here we are. We are on Chapter 10, Section 4, Factoring to Solve Quadratic Equations. We're doing exercises 1 through 25. I'm going to go a little quick. So if you need to slow it down, do what you got to do. But we are going to check our work. Okay, so, man, I pressed on the paper hard. Anyway, problems 1 through 4. Basically, they're giving you the factors. You set each of the factors equal to 0. Solve for the variable. In each case, almost each case, it's x. Number 3, it's t. The tricky part here is number 3. Students will often forget that t times the quantity of t plus 1, right here, that guy. It's one of your factors, so you have to set it equal to 0. So it's one of your possible answers to this quadratic equation. So t equals 0 or t equals -1. All right. Now 1 through 4, they're separating the factors out for you. So here, -3x, divide both sides by -3, x is 0. Okay, cool. Double check, make sure I'm not wrong. All right, we got a lot more here. Number 5. All right, so they're giving you the factors, two-step solving equations. Please make sure I did all of them right. I'm looking at them again. Looks like I'm doing pretty good so far. Manage your signs. Oh, nope, I found one. 6. I've got a negative just chilling here, and that is definitely not negative. That's a positive. I added 7 to both sides. Not sure where that negative came from. So this is one of those things, guys, that negative sign makes that answer absolutely incorrect. So it's a really good idea to go back over your work before you make a video for your students showing them how to do the work correctly. You know what I mean? All right, so here we go. Yep, that looks good. 7. Okay, so 7. Now they aren't giving us the factors. Now we have to factor this trinomial ourselves, right? So I'm going to go, okay. Let's see here, x5, x, okay, yep, that's going to work. Now I've got two factors, x plus 5 or x plus 2. Subtract, solve, x is -5 or x is -2. Okay, same thing here. This little work right here is my mental organization for finding the factors. If there were a lot of different things to try, I would be trying a lot of different numbers here, different combinations. You guys have seen me do this in class. So anyway, here we go. Yep, that looks good. Oh, yeah, seriously. Okay. I can't slide it. All right, there we go. So here we are with b squared plus 3b minus 4. +4, -1, solve b equals -4 or b equals +1. All right, I did forget right here to put equals 0. That's pretty inconsistent of me. I do have it almost everywhere else. Forgot the equals 0 over here because these two factors aren't just kind of chilling out there by themselves. They are part of the quadratic equation, which means they need to equal 0. All right, so here we are, different signs. Largest of the two is going to be negative. Yep, looks good. Negative, minus, plus, plus, plus. Yep, all that looks good.
Oh no, 11's weird. They've changed things. Well, no, just basic factoring. Factor out a w. W has to be one of your factors that equals 0, so that's one of your answers. The other one that you're left with is w minus 8, add 8 to both sides. Bam!
Okay, number 12. We're going to factor this guy out. Both of the signs are the same, so that means the sum of them has to be 16. So they're both negative here. Remember those rules for the factoring quadratics. All right, add 5 to both sides, add 11 to both sides. X is either 5 or 11. Notice how we're not getting any quadratic equations with no solution. All right, so hopefully you're wondering, like, why is that happening? And what would I do if that happened, and what in the world would it look like? What would it look like? What would a quadratic equation like this look like with no solutions here? All right, so we'll see. Okay. Muy bien. Okay. Here, factor out. Signs are different. Difference of the factors is going to be 3, so that's 5 and 2. 2 is positive, 5 is negative. Therefore, get out of the way, little toolbar, and we will see that k equals either negative 2 or positive 5. 14, factor that guy out. Signs are different. Difference of the signs equals a positive 1, so that gives us 4 and 3. You're not going to use 6 and 2. You're not going to use 12 and 1. So you might have noticed the handwriting changed. My daughter jumped in at this point and decided to work a couple out. So you'll notice the handwriting's a little bit different. She was bored. So, yep, all those look good. Number 15. We have to add 15 to both sides. That gives us our quadratic equation in standard form. Plus 15 means that our signs are the same, which means the sum of the factors need to be 8. That gives us 5 and 3, no problem. Those are solutions. Factoring here, we're going to subtract 28 from both sides. The signs are different. Difference of the signs must be 3, with the larger of the two being negative. Larger of the two being negative. Difference of signs. Different signs. Add 7 to both sides. T equals 7. Subtract 4 from both sides. T equals negative 4. She just forgot the little or right there. And a little or right here. Okay, 17. 17 is a lot like 11, and I think it was 3. We are going to subtract 6n from both sides to get it into standard form. Factor out the n. That n is one of our factors, therefore it equals 0. N minus 6 is the other factor. She forgot the equals 0 here. Oops, like father, like daughter. And she's added 6 to both sides. N equals 6. We're good to go. 18. 18, now we have a coefficient of c squared, so our a is no longer 1, our a value. Remember that, standard form. So our a value is not 1. In this case, it's 2. We need to figure out, we've got our factors of 5 here. 2 times negative 1, awesome. Negative 5 times 1, that's negative 5. So that gives us our negative 7c. We knew both the signs are going to be negative because the final sign here is positive. Muy bien. Okay. Add 5 to both sides, divide by 2, done. Add 1 to both sides, done. All right. 19. 19, do the same thing. We need to add 5 to both sides. Gets us our quadratic equation in standard form. Factor. 1 times 5. Oops, sorry. Nope. 1 times 1 is 1q. 3 times 5 is 15q. That gives us our 16q in the middle. Both signs are the same. Both signs are positive. That got us here. Set both factors equal to 0. Subtract by 5. Q equals negative 5. That's a 1. That's a 1, not a 7. Kind of looks like it could be a 7, right? But no, it's a 1. All right, those are the correct answers there. 20. Subtract 25 from both sides. Now here's an opportunity to recognize a special case scenario. You might be thinking, hey, wait a minute, where's my b? There's no middle here. What's going on? This is a difference of squares, folks. Difference of squares means that you take the square root of the first term, 2y, and the square root of the second term, 5, and you create two factors, one where the sign is negative, one where the sign is positive, because then negative 5 times 2y is negative 10y, positive 5 times 2y is positive 10y, and in the middle they cancel each other out, therefore no middle term. Negative 5 times positive 5 is negative 25. Anyway, takes us down to here where we set both of our factors equal to 0, add 5, divide by 2, done. Subtract 5, divide by 2, done. Awesome. You'll notice that we end up with this scenario. Basically the same factor plus or minus, right? Good. All right. 21. All right, we are in our real world problem solving. So we have the sides of a square are all increased by 3 centimeters. The area of the new square is 64. Therefore, area is side times side. The area is 64. We have our side is some value with 3 added to it. So we've got side times side. She literally wrote them out side by side. I'll explain this here in a minute. Foils everything out. X squared plus 6x equals 9. Subtract 64 from both sides. Where'd the 64 come from? That's the area of the square. Side times side equals area. Subtract 64 from both sides. We end up with this guy down here. We factor him. Signs are different. The larger of the two is going to be positive. 55, you only have 11 and 5. You don't have any options here. So x plus 11 times x minus 5. She did kind of skip that step, but we'll forgive her. Set both of those factors equal to 0, and you have x equaling negative 11, but that's not helpful because that's a negative measurement. No bueno. X minus 5, add 5 to both sides, x equals 5. She forgot her units. Those units are centimeters, so that should be 5 centimeters. Okay, so on the right-hand side, though, since a square is side squared, I wanted to show you guys a different way of doing this. So if I just written it out, x plus 3 squared, and subtract 64 from both sides, bam, I end up with a quadratic equation with a difference of squares, right? I have this term squared minus 64, which is a perfect square. Therefore, I use my special case scenario to factor this out. I take the square root of the first one, x plus 3, minus the square root of the second one, square root of the first one, plus the square root of the second one. Interesting, right? Well, I thought so. Anyway, simplify, 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 and you end up with the same darn thing. Math is kind of interesting that way. You might take different paths, but they will all lead to the same answer. At least they should. So this is another way of doing it. Either way, totally stoked. Just don't forget units. They're centimeters. All right, 22. Do we have another real world problem? This time it is volume. They give you the volume formula. You'll see that I will draw a diagram here so that I know the volume I'm talking about, because lots of different three-dimensional shapes have volume. I'll let the irony, yeah, all three-dimensional. Anyway, so we have the volume of a box, 280 cubic inches. Volume is going to be the dimensions of that box multiplied by each other. They gave you all three dimensions here. Oh, good, seriously, sorry. So then we set those three dimensions, the product of those three dimensions equaling the volume. Foil this guy out. Now, looking back at this, I could have made this a little bit more simple by dividing this 4. I could have divided both sides by 4, and that would have kept everything a little bit with smaller values, a lot easier to use. But I didn't. So I distributed the 4. Thing is, again, different paths, same answer at the end. So I distributed the 4 times 1, 4 times 7, 4 times 10. You can tell there's a couple of erasers here because I did it incorrectly. Yeah, I think I had a 5 here at one point. Anyway, so distribute that out, subtract 280 from both sides. 40 minus 280 is negative 240. Again, I could factor out a 4 at this point, but did I factor out a 4? No, I divided both sides by 4. Same thing right here. So I divided both sides by 4, reduced everything by 4. I could have done that right away. Anyway, so now we need to factor this guy out. 2 factors of 60, whose difference is 7. That's going to be 12 and 5. The only options here. The larger of the two. Oh, seriously. Oh, Vincent. This is what happens when you don't check your work. You get the wrong answer, folks. The larger of the two should have been positive here. So this should be n plus 12, and this should be n minus 5. I wonder if I'm doing problems wrong on purpose in every video just to make sure people are watching the video. Wouldn't that be kind of messed up? I wish I was that diabolical. I'm not. I just make mistakes. So yeah, ignore that. So this should be negative. This should totally be negative, and this should totally be positive. And if this were positive, then I would have gotten a negative 12 as an answer here, and a positive 5. So then positive 5 should have been the answer here. And if I do this really quick in my head, if this is 5, 5 plus 2 is 7. 7 times 4 is 28. 5 plus 5 is 10. 28 times 10 is 280. So a quick mental check. 5 is the correct answer. Definitely not 12. This number gets ridiculously huge if that's, well, not ridiculously, but you know what I mean, 12 if I substitute 12 in for n. No, correct answer, 5. And again, units, 5 inches. Whew, lots of places to make mistakes, right? All right, 23. Now we have the area of a rectangle. How do I know it's a rectangle? Because I drew a little rectangle right here, and it is 90 feet squared. That's an interesting little area there, 90 feet. I've seen it before. I think last section I don't know why they keep using 90. Anyway, the length of the rectangle is twice more than, wait, three more than 2 times the width. So 3 more than 2 times the width is the length. Okay, multiply the two together to get area. Multiply, distribute, subtract 90. We have this trinomial here. We factor that guy out. We figure out that we have a -6. Let's double check that. -6 times 15. Yep, that's 90. Positive 15, -12w. Yep, that gives me a positive 3w. So far, so good. Set each equal to 0. Subtract 15 from both sides. Divide by 2. Doesn't really matter here because a negative width makes no sense. The other factor is w minus 6. Add 6 to both sides. Now this time I checked my work. All right, I substituted in my 6 feet for length, and I figured out that the length was 15 feet, and of course 6 times 15 does give me 90. All right, so checking your work is super helpful. Do it. 24, we're almost there, just 2 more. So we have a right triangle here. We have a base, we have a height. The area of a triangle is 1/2 base times height. And according to the problem, that is 110 square feet. So the base is x and the height is 2 more than twice the base. And we just plug that guy in. So we have, I went ahead and multiplied everything by 2 to get rid of the half. So I've got 220 now. I distribute the x, 2x squared plus 2x. Easy peasy. Interesting. I could have technically distributed that half over here and got rid of the 2's. I could have done that. This 2 here and this 2 here. Anyway, just a different way of doing it. So I subtract 220 from both sides. 2x squared plus 2x minus 220. I end up factoring out the 2 here at the end, which again, like I said, I could have done earlier. But anyway, factor this trinomial. I get 2x plus 22 times the quantity x minus 10. Factor out the 2. I've got 2 times the quantity x plus 11 times the quantity x minus 10. I should recognize right now that this is going to be an unusable value. Instead, we can ignore the 2, right? Because there's no x here, so we don't have to set that equal to 0, and that would just be nonsense, right? Setting 2 equal to 0. 2 doesn't equal 0. Just doesn't. So it's not a pertinent factor. So we've got these 2 factors here that we solve for. We find out that it's 10 feet. Now, I need to substitute it in to find the height. Now, if I multiply 10 times 220, times 22, I get 220. And then because it's the area of a triangle, 1/2 of 220 is 110. It checks out. I really, again, should have checked my work in a whole nother box up here. Okay, please check your work, folks. Final one. Okay, consecutive number problems. Get used to them, folks. You're going to have a bunch of consecutive number problems over your mathematic life. Here we have 2 consecutive numbers, which means one number exists and it's x, and the consecutive number, the one following that number, is going to be x plus 1. All right, and there are 2 consecutive numbers that exist where their product is equal to 10 times the smaller number minus 14, or 14 less than 10 times the smaller number. So this is the mathematical representation of the sentence that was the problem in the book. Okay, so 2 consecutive numbers, the product of them, that's why we're multiplying, so the product of 2 consecutive numbers is equivalent to 14 less than 10 times the smallest number. These are son of a gun. You want to practice these. These are good logic problems. Distribute the x. Subtract 10x. I did 2 steps in one. Subtract 10x from both sides. And then add 14 to both sides. So we've got the positive 14 up in here. We have x minus 10x. It's negative 9x. And we're golden. So we have x squared minus 9x plus 14 equals 0. Factor that guy out. We know our signs are going to be the same. They're both going to be negative. They need to sum together to give us 9. factors are 2 and 7. So what's interesting here is that we find out that x could be 7 or it could be 2. Now, this isn't a measurement problem, so if one of those answers were negative, there's no problem with that. Negative numbers have consecutive numbers, next to them as well. So here's where I'm like, okay, wait, really, there's 2 possible answers here, so let's check them out. So first scenario, x is 2, and the next consecutive number is 3. So I go ahead and substitute in. The product of the 2 numbers, 2 consecutive numbers, is 6. 10 times the smallest number, minus 14, is also 6. So sure enough, it works. So I was like, all right, interesting enough. Let's check the other one, 7, and the consecutive value of 8. 7 times 8 is 56. 10 times the smaller number, which is 7, is 70 minus 14 is, holy smokes, 56. Crazy beans. Both of those sets of numbers work. Give it a shot. Try another pair of consecutive numbers. I would bet it's not going to work. All right, just try it. 10 and 11, not going to work. Negative 6 and negative 4, not going to work. Negative 2 and negative 3, not going to work. Negative 7, negative 8, not going to work. It's just not going to work. Okay, so that takes us to the end of our lesson set. If all this was awesome and easy for you, don't forget to give the challenge question a shot. And that's it for me, folks. Hope you enjoyed the little surprise goof video in the middle. Have a good one. Bye. If you're not all thumbs up right now, let me know. Ask for help. Send me a message in Synergy.